Hi, welcome to Algebra 2 Honors Chapter 2 Review Part 1. I will probably have 3 parts to this. I have to talk as fast as I can because we have less than 10 minutes to do the first segment, or else I won't get it in YouTube in time. Problem number 1 is 13 minus 2x over 3 is less than 7. Please, if you have some issues with what I'm saying too fast or stuff like that, just press pause on your YouTube button and then you can write the problem down and solve it out later. Okay? Or actually I would pause it first, see if you can solve it out first, and then we'll go over this later. First thing we do is we get rid of the 3 by multiplying by 3 to both sides. 13 minus 2x is less than 21. Subtract 13 to both sides. You get negative 2x is less than 21, that's 8 right there. And x is greater than negative 4. Because we divided by negative 2 to both sides, switch the inequality. Problem number 2. Absolute value of 3x minus 1 is greater than 7. Notice that this is greater than, so what we do is we have to branch it off. And always a greater situation, branch it off, put the or in between. First step we do is bring it straight on down without the absolute value. So it's 3x minus 1 is greater than 7. Or, the second part is we bring it on straight down, switch the inequality, switch the sign on the number. If we add 1 to both sides, 3x is greater than 8, x is greater than 8/3. Or, add 1, you get 3x is less than negative 6. X is less than negative 2. Those are your answers. Graphically, what it's doing is going negative 2, 8/3. X is greater than 8/3, which means it's going to the right. It's an open circle. Or to the left, x is smaller than negative 2, which is located right over there. Let's look at number 3 now. Similar problem, except we're going to have a less than symbol. Absolute value of 2x plus 1 is going to be less than or equal to 3 this time. Notice the less than or equal to. The first thing we do is we bring it straight on down without the absolute value. It's less than or equal to 3. And it's going to be in between, because the absolute value is between 3 and negative 3. You have to put the inequality with the negative on this portion right over there. And then solving it out, subtracting 1 to both sides, you get negative 4 is less than 2x, which is less than 2. Dividing by 2 to both sides, you get x is less than equal to 1, but greater than negative 2. And that's your mathematical answer. Graphing it out, negative 2, 1, and it's going to be closed circle. Whoops, excuse me, wrong way. X is between negative 2 and 1. It's going to be right over there. Okay. Let's look at another problem. Absolute value of 2x plus 1 is less than negative 3. Well, instead of just start, branching them off or resetting the equations, can the absolute value of a number be less than negative 3? Well, absolute values are always non-negative or positive or zero numbers. It cannot be less than negative 3. Therefore, there's no solution. Please make sure that on this caveat type problem that you have a less than or greater than equal to a positive number. Okay? So let's look at problem number 4. A little bit different type of problem. One is less than or equal to absolute value of 2x plus 3, which is less than 7. When the inequality is on both sides, you have to branch it off. Okay? The first branching off is straight down without the absolute value. The second part is you write it straight on down, 2x plus 3, change the way the inequalities are reversed, and negate the sign here and negate the sign here. That's the setup. Once you get the setup, it's all mechanics from here, so it should be quite easy. Subtracting 3 to both sides, you get negative 2 is less than or equal to 2x, which is less than 4. X is going to be between 2 and negative 1. Or, we're going to flip this first. Negative 7 is less than 2x plus 3, which is less than or equal to negative 1. Subtracting 3 to both sides. Negative 10 is less than 2x, which is less than or equal to negative 4. Dividing by 2 to both sides, negative 5 is less than x, which is less than or equal to negative 2. That's your mathematical answer. Let's get our graphical answer for that. It's going to be between negative 5 and negative 2. It's going to be between negative 1 and 2. It's going to be inclusive at negative 1. Exclusive here, so it's going to be in between. And it's going to have equal to negative 2 here. And it's going to be in between negative 5 and negative 2. So that's your graphical answer and your mathematical answer. Let's look at one more question that's similar to this. What if I give you something like this instead? Negative 1 is less than or equal to the absolute value of 2x plus 3, which is less than 7. You're going to have a problem. Just like previously, absolute value cannot equal a negative number, so we have to reset the equation from 0. Just in case Mr. Pakula or Mr. Tolkman might give you something, a twister or something with a twist or a trick or a curveball, you have to reset it this way and then branch it off and solve out the problems. Okay? And actually, you can actually solve it out and plug in numbers and see which one actually works. The last question that I have for part A is number 5. X plus 2 times x minus 4 squared times x minus 1 is greater than 0. Well, we find the roots first. X equals negative 2, x equals 4, x equals 1. In this situation, what we're going to do is we're going to try to graph it out first. Negative 2, 1, and then 4. It's a double root right over there because of this power. We're going to put open circles here, 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 because it's greater than, not equal to 0, so it cannot be solid. The degree is 4. 1, 2, 3, and 4. And the leading coefficient is positive, which means the end behavior is going to go up. So double root, it bounces back up. Single root goes down, goes through it, and single root again. You notice that the end behavior is positive, just like what we did here. If you have problems with this, let me know and I'll try to create another video for this. It's positive here, negative, positive, positive, and positive. Notice that the y values are positive, here, here, and it's only negative here. When is it greater than 0 or positive? It's between here, here, and here. So our answer is x is going to be less than negative 2, or x is going to be greater than 1. X cannot equal 4. You got to put this down. If you put this down, if you don't put this down, it's wrong. So that's your mathematical answer. Good luck on your test. Thanks.